Alright, first let me actually... There we go. Alright. We are now live. We will begin the integration bee shortly. There we go. We are live. I gotta refresh. There we go. Awesome. Awesome. Alright. We are beginning the most exciting day. Oh shiz. Welcome to Integration Bee Austria, Day 2, where we will begin semifinals and finals. This is what we have currently. We do have just about like one round, a few matches in quarterfinals. We couldn't finish in day 1 because of the venue. We had to move out at a certain time. So we'll just finish off, starting off with these 2 contestants first, and then we will begin semifinals. I do also want to mention that we actually have 4 IMO contestants competing in this integration bee. We have 1 bronze medalist, Georg Weissbier, and then we have 3 silver medalists, William Shi, Martin Bierbaumer, and Dominic Potard. So this is what we have right now currently, and we're just kind of waiting. So this is our bracket right now. Lower your voice a little. Oh, is my voice, am I a bit too loud? I can lower, oh, Jesus. Here, I got you. Let me put it in 22, because I was a little too low before. How's that now? Is my voice, let me know if my voice is too soft, because in day 1 my voice was a bit too quiet. But how is it now? Just let me know if my voice is a bit too quiet, then I'll kind of amplify it, just like about like 2 decibels. If that would ever help. That's better? Okay, awesome. Alright. What else? Other than that, yeah, anyone who's coming up, welcome to, oh god, almost forgot one thing. There we go. So, welcome to Vienna Integration Bee. This is Integration Bee Austria for fall 2024. We are beginning about 1 match of quarterfinals to finish up, and then we will begin semifinals and finals for today. It's going to be just a little quieter. Oh, quiet. Just a little bit. Lower down. Should I lower down my voice a little bit more? Just a little. I'll do 2 decibels off. I'll go like that. We'll do 20 decibels. Okay. Yeah, it's good now. Alright. Awesome. Day 2 is going to be legendary. Indeed, it will be. It's going to be very, very legendary. Yeah. What's the weather? What's the weather like in Vienna? Yesterday it was sunny, cloudy, and cold. What's it like now at Vienna? How's the weather? I'm assuming it's the same old cloudy, sunny, cold. The problems we have for day 2 are absolutely beautiful. Oh shiz. What were we just about to see? I am betting on. Oh. Hey! No gambling here. I am betting on. Weissbier.
Does anyone know where Thierry Framberg is?
Oh, weird. Oh. Maybe we might start. Looks like we might start. But for those who just came, this is our bracket right now. Okay, again, we're just gonna start off with 1 quarterfinals and then begin our semifinals until the finals round. Okay. But other than that, I think it's dark. Speaking about weather, continuing about weather at Vienna. I think it's dark now at Vienna, but it's dark only because things about to get serious in this integration bee. So it's going to be very, very exciting, very intense. We're all just getting ready here. Alright. So again, just to recap, all students are undergraduates. We've almost finished regular round in day 1. Right now we're trying to finish up for semifinals and finals round. Semifinals 4 minutes per integral, and finals round is 5 minutes per integral. And semifinals is the same as quarterfinals, where it's best of 3. For finals, it's going to be best of 5. So it's going to be very hectic. Some chaotic integrals. From the problems we saw yesterday, they were pretty difficult for regular rounds. So I think semifinals and finals, we might see integrals that may show no mercy. So it's going to be very chaotic. It's going to be very entertaining. And again, competitors only have like 1 guess per integral. So very pressuring. So I guess while everything's setting up, the person commentating me, I am Silver. I wouldn't say I'm a retired. Technically, I'm kind of a retired speed integrator, but yeah, I am a speed integrator. I make integration bee content in my YouTube channel, and I write problems. This is kind of yesterday was my first time commentating, so I'm not much of a good commentator. I hope I am now, but I still have a lot to improve. This is what happens when you hire an introvert to commentate. But I am very honored to be invited to commentate for Integration Bee Austria. So huge thanks to Sam and the other organizers for inviting me. Today the weather is wet. Is it raining at Vienna? Oh shiz. It's raining, dark and cloudy at Vienna. That's how you know shit's about to go down in this integration bee. It's gonna be crazy. one thing I didn't know about this integration bee is you can answer in complex form, which is not usual, but surprisingly you can put your answers in complex form. That happened, it was spring 2024. I did not know that, so I just gotta be aware of that. We have a lot more new people coming in. Again, we're just getting ready, start. For those who just came in, I could actually go like this. Awesome. So this is our bracket right now. We will first finish off our quarterfinals with these two competitors first, because we weren't able to finish in time yesterday due to the venue schedule. So right now we're just going to finish off with these two competitors, and then we'll go ahead and get right into the semifinals and finals round. So it's going to be very crazy. Again, I also want to mention that there are 4 IMO contestants competing in this integration bee. 1 bronze medalist, Georg Weisbier, and 3 silver medalists, William Shi, Martin Bierbaumer, and Dominic Potard. It's going to be crazy. And this is what results we have so far. Yeah. Very crazy. Right now we're just kind of getting started.
I think we can start.
Oh, and here we go.
Ladies, gentlemen, integral
Louder.
lovers, and whoever else is in this room, I want to welcome you all to the Integration Bee Fall 2024, the second day. Today we see who is the master integrator and which one of your friends or enemies is going to get which prize. So, you can move to the next slide. What is Integration Bee? I'm not going to say it again because we want to move quick so we get to the rounds. Integration Bee is what's going to happen here today and what happened yesterday, and I'm pretty sure you all know that. So moving on, I do have to thank the sponsors because this is the day when the sponsors actually matter the most. Because we can start with Pepsi, and if what some of you don't know already, there is pretty much infinite Pepsi over there in the back. We have Pepsi and Pepsi Zero, or Max, in that corner. Just take as many as you want. Just make sure to balance out the Pepsi with the Pepsi without sugar, because without sugar, not so good. Moving on, and this is probably the most interesting sponsor to us, and the one that helped us so much. Formamind, as I said yesterday as well, is a software development company from Poland, and they make our new website. And they also make the system which allows us to show the integrals in the way which we presented them on these 2 projectors yesterday, and we will do the same today. So we want to thank them a lot. And now we move on to the sponsor who is the most important to the contestants, because Smarakis, who's an accounting and IT support company from Vienna, was kind enough to give us almost all the prizes that the contestants will receive today, which are all more or less gadgets you will see at the end, because this time, compared to last time, we will have an actual award ceremony, hoping that we don't get over the time limit. And then everyone, including the contestants who lost yesterday, will come on stage and get their certificates, respectively, for the first 3 positions, also an actual prize. So we move on to the team. This is again very short. I told you yesterday. Max sadly is missing. Max is part of the core of this team, and we appreciate him a lot. Sam, that would be me. I studied math here. Same with Konsti, same with Adrian. Konsti and Adrian are really big brains behind this. Adrian made some crazy integrals that some of you loved and some of you hated. And we promise that today will be the same. Moving on, we have Jonas, who is not present here right now, but he will be in around 20 minutes, and he's going to take pictures of you. Saying this, I should also mention again
it is at the
that
max
if
volume.
any of you wish that there are no pictures taken of you, please tell Jonas or any of us if you're uncomfortable with that, because we want to be fair to everyone. Secondly, we have silver. And for those of you who don't know, this event yesterday, same as today, is live streamed online with live commentary from the integral YouTuber Silver, and that stream is on our channel. So if you have any friends that cannot participate or cannot come and see because they are busy or something, or they are somewhere else on a holiday, please tell them and they can hop in the stream. Last but not least, we have two very big brains. One from London, Lucas Trakimas, and one from Texas, Evan Griffin. They are also two of our integral creators who make those funky integrals which you are about to see. Moving on. I would like to have these special thanks again. I'm not going to read to the entire list because I already read it yesterday, but basically we want to thank the university. We want to thank those two particular contestants, which you can see there, which you will also see integrating today. Because of their efforts to help this event without actually getting anything in return. And last but not least, the last four names are our volunteers who are operating the cameras and did so yesterday as well. So moving on, I'm going to say this again because there is a little hint, if you heard it yesterday. Not only do we celebrate 100 years of quantum mechanics next year in 2025, but this might or might not be also related to the secret prize which the winner will receive. Moving on. We have the rules, you know the rules, so I'm going to tell you the structure. What is the structure? Well, today it's a bit different. We have one quarterfinal left, and you can go on to the next slide, and the next slide. It's the same as that. This can be seen on our website if you just go to Events, Integration Week Fall 2024. We have this quarterfinal left between Suo and Sierikova. That will be the first match played. That is still 3 minutes per integral, and it's still most out of 3 integrals. So again, if there's 3 integrals and it's 1-0, that is sufficient for one contestant to go through. Then we're going to have 2 semifinals. One is already known and the other one is not known. The semifinals are also most out of 3, but the integrals are going to have an allowed time of 4 minutes. Then we are going to have a small final to determine who is the third place and who gets the prize between the people who will sadly lose in the 2 semifinals. That will have the same structure as a semifinal, so most out of 3 and 4 minutes per integral. Last but not least, maybe the thing which attracts the most people, to see who the master integrator is, we will have the grand final, which will be a most out of 5 with 5 minutes per integral. Because the integrals are a bit more interesting, let's say so. So, I think we can already get this going. Again, for the friends who are at home, tell them about the live stream. Otherwise, enjoy yourselves, get some Pepsi, and let's start integrating.
Yeah! We're going to...
That being said, I'm inviting the quarterfinalists to the board.
That's right, we're going to go ahead and finish off our quarterfinals. We just have these 2 last contestants that we didn't finish up for yesterday. And here they are.
And also one little mention for the crowd home watching online and also for you, so it's easier to remember, we will update the score between after every single integral if it needs to be updated, just for more clarity. So all contestants are ready. Okay, let's integrate.
Yeah, let me go ahead and just kind of lower the volume for the commotion. Alright, so we have our integral. Wow. Denotes the complex modulus. Yeah, I'd be a little struck by that too. Wow, from -4 to 4. We have the modulus of square root of 17x cubed plus square root of -8x cubed. Wow. Yeah, no, I don't blame I don't blame the person on the left. I do the same too. I forgot to mention those who are wondering the 0 0 on the board. That's just to help keep track of the scores for semifinals and finals, because it's just out of, or probably for finals round, just to help better keep track of scores. But right now, both sides are trying to understand how to even integrate this, because we're dealing with complex modulus. That negative inside the square root is really distracting. Guess 0. That's very risky to do sometimes. It's not always great to guess 0, because then you give the other opponent chance to finish up very kind of take their time with their time limit. And now you just have to hope that they won't be able to solve it. Very risky guess, but I don't blame them. And now we playing some Hangman. Again, this is exactly what I would do in Integration B as well if I'm thrown with an integral that I have no idea about. Like, wow. But coming back again, like the integral, like that -8 is very distracting. And -8 inside of a square root. I don't know how that's, I mean, imaginary, I guess, and then complex modulus. That's like what? The square root of a squared plus b squared, so that's going to be like, you're integrating the square root of...
30 seconds left.
Oh, no. Yeah, the square root of... You're integrating the square root of 17x cubed plus 60... No, 8x cubed. Oh, okay. I see what's going on now. It would be a little unfair if none of the competitors know how to do complex modulus, but yeah, no, I don't blame both of them. I think there might be a kind of a lack of definition of a complex modulus, but I think it's the power rule, maybe. I think, yeah, 128 is the answer. Yeah, I don't know. I think it was just simple power. I think you just used the complex modulus definition. But I don't... I could be wrong.
Just warming up, so I think they deserve your support for the next integral.
Right. For the next integral. We're gonna go ahead and get ready for the next integral now. Yeah, I don't blame both of the contestants for that. It was a weird, gimmicky integral using the complex modulus.
Okay, both contestants ready? Okay, let's go.
Alright. Coming with our next integral, we have the integral from 0. I can't exactly read it. Is that a half? That might be a half. With an inverse tangent of 2x squared root of 1 minus x squared all over 1 minus 2x squared. Look, that square root is very suspicious. I would... Oh no, yeah, actually, no, I would immediately let x equal sine theta, because that square root and the 1 minus 2x squared is very suspicious. So that is kind of hinting to let x equal sine theta. But none of these contestants are using that. Person on the left is trying to rewrite the integral in a different form. I'm not exactly sure what's going on. It looks more... I don't know what's going on there. Person on the right seems to be a little stuck trying to approach this. But that radical, that square root of 1 minus x squared should give you a hint, like try x sine theta. Even if it may not work, just try it and then see where it goes. At least if it takes you to a trap or somewhere, you at least have an idea of, okay, I know what to do for my next approach, and so on. Oh, there we go. Trig sub, there you go. X equals sine t. Yeah, just try to write as fast as you can, trying to get this done, especially in about 1 minute. Yeah. Person on the right is also doing the same thing, let x equal sine theta. See where it takes you. So that should give like sine 2 theta all over cosine 2 theta. Yeah. That should give you the freedom to just have 2 theta. Oh, but then you have 2 theta cosine theta, so you're also left with integration by parts as well. And we have an answer already.
That's wrong.
1/4? Is that a guess? I'm not exactly sure what she did there, but now the person on the left is writing very fast, trying to get past the timer. Oh, but does he know it's 2 theta cosine theta? Oh, dang. Oh, come on. 3 seconds left.
That is wrong answer.
Dang. Root 3 minus 2 plus pi over 6. Yeah. It was, if you let x equal sine theta, you're able to simplify it down to 2 theta cosine theta because the bound allows you to do that. It doesn't surpass the domain. So but it was tricky to the look of the integral was very scary, so I don't blame any of these contestants. Very, very nice try. Very nice try. Yeah, I think x equals sine theta would have been the way to go. Alright, we're on to our next integral. We have the integral of e to the x times a rational polynomial 1 plus x minus x squared over 1 minus 2x plus x squared. Ooh, notice something at the denominator. Yeah, there you go. Person on the left immediately simplifies that into x minus 1 squared. Try to see a big picture of what is going on. That denominator is very suspicious. Maybe try reverse quotient rule or something. Maybe factor out that x minus x squared into x 1 minus x or something. There could be a reverse product rule going on in this integral. You know, an e to the x times a rational polynomial, you know there's a suspicion of a reverse product rule or a reverse quotient rule. The only thing is you just have to hunt for that function. If one function is e to the x, what is the other? That's what you have to look for. So you're gonna have to go function hunting especially when you're doing reverse quotient rule. Right now the person on the left is really trying to find what that function is. And you have to make sure it's not the wrong function because you only have one guess. And you have to be careful not to miss any coefficients or a negative in your answer. But keeping that denominator as x minus 1 squared is very helpful to keep track. So less distracting. Right now both of them are a little stuck on where to go. It looks like the person on the left is trying to do partial fractions. But with the e to the x, I would not recommend it. Unless, or I guess you could, actually now I think about it. You could do it. That's one way to do it, but there must be something that easily simplifies. I think the person on the right is doing polynomial division. Looks like it. I mean, they both, top and bottom, are quadratic polynomials, but I guess it could kind of help, but I'm not sure where to go after that. Because that e to the x is really bothersome for both of these contestants. And time is up. Oh. No. 4 seconds. Yeah, no, there's no way. And then a last second answer.
That is correct.
Oh my god! What? What? Wow. We have the luckiest competitor here. Oh my goodness. A last second answer and it was correct. Oh, we might have a little debate here. Oh, I'm not exactly sure what's going on. Oh, I don't think they might. Okay. I think someone debated that because it was time's up, they won't allow it. So they're going to continue.
Okay, now we move on to tiebreakers.
Very generous.
Here, every integral is decisive.
Wow. I think they're going to move on to tiebreaker now. Tiebreaker integral, yeah.
Ready?
Alright.
Ready? Okay, let's go.
Here we go. Here comes our tiebreaker integral. What is that? From integral from 0 to 2. What? What is that sharp symbol? I've never seen that math notation in my life. A sharp symbol? There's no explanation to that. I don't understand. Oh wait, what is that? Oh, I didn't quite hear clearly, but I mean that is a very weird looking piecewise integral. A sharp symbol. Yeah, I'm not exactly sure what that is, but I guess they explained it to contestants. I didn't quite hear clearly, but there one on the left is graphing. Oh, that's the cardinality. Okay. I've never seen that math notation before for cardinality. But that makes a lot of sense now. But dang, finding the cardinality, that's actually brutal. So now you're really kind of graphing helps to find the intervals between those two functions and kind of. Oh god. Oh, but you have to remember it's from 0 to 2, so you're only accounting for the intervals from 0 to 2. So only x between 0 and 2. But it's still very tricky to kind of count the cardinality. Again, you only have one guess for this. So you have to count very carefully. 5? Is that incorrect? I think so, yeah, because the timer is still continuing. So it's not 5. Dang. Finding the cardinality. That's like one of the advanced piecewise integrals to solve, is finding the cardinality of a function for a certain interval is just crazy. Wow. We have 20 seconds left. Graphing was a very good approach though, but I don't know how she's gonna approach this in less than 10 seconds. That's a very difficult integral. Yeah, I wouldn't be able to find a way. What was the answer? 5 minus root 2. Dang. He was missing a root 2 somewhere. I don't exactly understand how a cardinality can have an irrational number. That's just me. I know nothing about these concepts for advanced math, but that's cruel. That was a very cruel integral, especially for a tiebreaker. But we're gonna move on to a next tiebreaker integral now, and we have the integral. Oh my goodness! What in the Christmas tree is that? The integral of each. I can't even see the exponents. It's a little blurry. I swear, the quality is in 1080, 60 frames per second, and just by the look of these on the whiteboard, I can't tell. None of these are trig functions on the exponents, so they're all just exponents. Now it's just in a matter of who can do the algebra and integrate it very fast. It looks like an easy integral, but when it comes to speed integration, you have to be very accurate when you're rushing against an opponent. You have to make sure that you don't miss any constants, you didn't miscalculate any coefficients. Now it's just a matter of algebra. Oh my god. Yeah, don't get problem shock. Just start simplifying everything if you need to. Go slow if you need to, if you don't want to lose accuracy. Yeah, that's what the person on the left is doing, just carefully, not even trying to do it mentally, just write it all out, counting, so that, is that 420? I'm so done. I cannot believe this. One of the exponents is 420, it looks like 420x, I could be wrong, but yeah, the person on the left is trying carefully to compute everything for the exponent, because you do not want to mess this up. Otherwise, you're gonna give your opponent more time to just patiently solve it, and you would be done for. So, but it looks like
that is correct.
Yeah, there you go. Accuracy, nice. Very nice. Yeah, there was a lot going on in the exponent.
This was the tiebreaker. You are into the semifinals.
Wow. And that concludes quarterfinals. I think we're going to be moving on to semifinals. Now the integrals are going to be very, very scary now.
Alright, now we have all 4 semifinalists.
Oh boy.
So we can start
4
with the
semifinalists
semifinal
now.
between Weisfield and Pulta.
Ooh.
I think this really deserves some applause.
Oh boy. Things are about to go down now. We have 2 IMO contestants going against each other. Georg and Dominic. This is going to be extremely intense. Thank you to the cameraman for zooming in, making the board a lot easier to read. And for the viewers. Yeah, those who are watching right now, you should be able to put your quality in 1080p, 60 frames per second.
Still most out of 3 and then followed by tiebreakers if necessary.
But we are about to get into semifinals now. Things are going to get very, very crazy. Especially when 2 IMO contestants go at each other.
Let's go.
We have already a triple integral already set up for luck, for good luck. Alright, here comes our first semifinal integral. Ooh, and we have the integral from 1 to infinity. Technically a fractional part of x over x cubed dx. This looks like a famous Gauss sum, it looks like the answer is pi squared over 6, but I could be wrong. This is a very famous integral. It shows up a lot in a lot of integration bees. Now it's the matter of who can get it fast, and look at the person on the right is already trying to write down the sum very fast. very nicely. Now it's just trying not to mess up any constants and just trying not to lose accuracy. Person on the left is graphing, trying to... Graphing also helps because if you're very good with geometry and graphing, you can just easily compute the area because a lot of piecewise functions, they're just straight lines, no curves, so all you're computing is just the area of a bunch of squares, triangles, and trapezoids. Ooh, nice catch on the person on the right, trying to make sure not to mess up any coefficients. There's a lot written down for... right now we're in 2 minutes and 30 seconds. This is a very good, at a good position. Yeah, so again, for semifinals, we only have like 4 minutes per integral, so you have a lot more time because these integrals are going to be a lot harder. So you definitely need to spare your time much more. More time to think, more time to experiment with the integral. Right now, the person on the right is left with a weird sum. Partial fractions, decompose it, cancel something. He's trying to carefully compute it, make sure there are no miscalculations because you only have one shot. Utilizing the entire board. Ooh, -1 plus the sum. Ooh, very close. 1 minute and 30 seconds remaining. The person on the left is constructively summing it. Try to see a pattern and then construct it into a sum and then create a summation that would possibly help him answer the integral. Both are very at a good position right now, but they need to hurry in under 1 minute. They need to compute that sum very quickly. It's just a matter of who can get it first. Ooh. The progress on the person on the right. The sum. There's a lot going on in that sum. You gotta be very extremely careful not to miss anything. Hopefully there's no miscalculations. Wow, 16 seconds left. That's how difficult these piecewise functions are. It's the summation that's like the trickiest to compute. Because you have to maneuver and manipulate the sum in a way that you can answer it. A familiar. Oh! We might have an answer? Ooh! Both circled an answer. Pi square over 12? That looks like pi square over 4. 3/2 minus pi square over 4. 1 minus pi square over 12. Wow.
Both answers are wrong, but very close.
Very close. Both are very, very close. Oh, he forgot about the... Dang. He had the answer. He just completely forgot about that one that he integrated. Ah, dang. Yeah, I don't blame him. Very pressuring. Adrenaline's kicking in now. Now it's just we don't know what the next integral is gonna be. If it's gonna be any worse or if it's gonna be even nicer. You just gotta hope. Just hope. Alright. Now we're just getting ready for the next integral.
Let's go.
Alright. See what integral we have now? We have the integral, a sum from n equal to 0 to infinity, from sine to power of 2n plus 1. Wow. That looks like a... Oh wait, no, but it's indefinite? Because it's an indefinite integral, that means you're not allowed to use geometric series then, right? Oh no, you should be able to. No, you should be able to use geometric series because notice that sine of x is in the range of -1 to 1, right? You can't surpass 1. You should be all the way, but then you have to consider what if x was pi over 2 or negative pi over 2. It can equal to 1 and it can equal to -1. So you have to think about that. But I mean, that's just, then you could just answer it in a piecewise form, right? I'm not sure. But both are writing very intensely. Okay, so one did use geometric series, and the person on the right. The person on the left is also... Oh! The person on the left also did use geometric series. Okay. Yeah, no, that's what I would consider too, is consider using geometric series and then solve for the integral. So I guess you could use geometric series then. Excuse me. Yeah. Because the sine of x is at a range of -1 to 1. So it seems safe. Oh, secant x. It seems correct too. Yeah. It is the correct answer. Dang. Very quick too. Very fast. Very nice. Very nice. Now things are getting very intense now. Wow. That's a 1. Yeah. Just to keep track of the score. Best out of... Semifinals is best out of 3, right? Yeah, it is best out of 3. Yeah. Adrenaline's really kicking in now. Adrenaline's really kicking in. Ooh, possibly the last integral for these two competitors. Alright, we have the integral from 0 to pi over 2. Log base 10 sine square plus log base 10 cosine square. Oh, no way. Oh, come on. Do not fall for this. Do not guess, log 1. I'm glad both of them didn't quickly rush and answer incorrectly. Very patient. Right now they're both just trying to simplify everything. We got 1. Person on the left. We got log of sine square, cosine square. Take that 2 out. There you go. And now you have sine 2x. Oh, wait. No, you can't do that. Oh, the person forgot about the half. Oh, he cannot forget about that half. Oh, no. That might cost him. Yeah, there you go. The person on the right, don't forget about that half. Do not forget about that half. A very common mistake when speed integrating. Okay, we got log 4 pi over 2 at the side. Now you just make sure to not forget that. Now it's just log ln of sine of x. Oh, but it's log base 10 though. You cannot forget about the ln of 10 at the bottom. Very, very cruel integral actually. Cannot forget about that log base 10. Unless it's not, unless it's used as natural, but I'm not sure. But I'm pretty sure they're considering log base 10, so you have to write ln of 10 at the bottom. I'm not entirely sure. Oh no. Person on the right seems to be in a loophole. Unless they can figure out a way. Yeah, the integral of ln of sine of x is a very popular integral. But at the same time, it is very tricky to solve it if you don't know what you're doing. It's very tricky to solve ln of sine of x from 0 to pi over 2. It's a very popular integral. Person on the left looks like integration by parts, but the leftover stuff is really kind of holding him. Person on the right is using Queen's rule. It's a good I mean, I don't. It's good approach, a good experimental thing, but again, it's back in a loophole. Nothing's happening. He's trying to get himself out of the loophole, but no. Both contestants are stuck right now. Yeah, ln of sine of x. You need to like. Yeah, it's a very tricky integral if you've never seen it before. It's a very tricky integral. It does not equal to 0. It does not equal to a common constant. Very, very tricky integral. It seems like the person on the left is trying to kind of rewrite it in a different format. Trying to think of a new approach. And also try not to forget that log base 10. There you go. Oh, we have an answer? A guess? Negative pi log 10 4. Dang. Very close. Very close. Alright. Well, there you go. One's going up to finals round. Dang. Very, very close. Excuse me. Wow. Yeah, that integral is very tricky. If you've never seen the integral of ln of sine of x, it's a very popular tricky integral. But now we're gonna go ahead and pull up our next two contestants for semifinals. And then we're going to begin our finals round. It's going to be super, super intense. But again, in the semifinals, it's going to be best out of 3. Ooh, against 2 competitors, it's going to be crazy. Dang. Really great job on both of those 2 competitors, though. Alright, grabbing the Hagoromo chalk. The nice fine chalk. Now we go ahead and get ready. Yeah! Here we go.
Okay, again, also after 3 more minutes, are you both ready? Okay, let's go.
Alright. For our next integral, we have the integral of 1 to infinity. Oh, Jesus. We even have a floor function on top of a sum. Again, hangman for comfort. Oh, God. That looks like Taylor series. Actually, I would start rewriting it in terms of... That might look like a double sum. Is that a double sum? That looks like a double sum. Notice that that's all inside of a floor function. That's crazy. And that sum itself looks like a Taylor series. So that's a little suspicion there. Yeah, I kind of turn this into a double sum. Kind of make another sum k equal to 1 to infinity. Then let k be at the top of that sum. So it's like the denominator would have like a sum of n equal to 1 to k, or k minus 1. But you have to be very careful not to mislead anything. They're all in terms of floor functions. So I think you can make this whole integral into a double sum. It's a very weird sum. Very awkward sum. Because there's no x's by itself in this integral. So everything's just a summation. Man, this integral is technically a summation B, you guys. Nah, but this is very tricky. I can't even do this in my head. Like n negative 1 power n plus 1. Wait, there's a x plus 1 inside of a floor function. That's evil. The formatting in this integral is evil. So many distractions here. Yeah. Person on the left is trying carefully. A half. Dang. 1 minute 45 seconds left. That's a very risky guess. Because now that person on the right has more time and does not have to worry about beating the opponent. 1 over k. Yeah, that looks like a Taylor series inside that floor function as the denominator. But with a double sum, I don't know how that's gonna work. Maybe an integral inside of an integral. It's one of those sneaky tricks where it's like you turn it into a sum and then turn it back to an integral. I'm not sure. That's a very rare type of integral though. So least likely. But I mean, I've never seen an integral like this. So it could be one of those. That really looks like a Taylor series. It's kind of bothering me a little bit. N to the power of k. Like, think of it like if from n equal to 1 to k, and then we have what? From k negative 1, k plus 1 over n to the power of k. God, what is that? I wouldn't even know how to handle that double sum. We have about 20 seconds left. I don't know how you would even speed integrate this carefully. 11, 10 seconds left. Maybe make a guess somehow, educated guess. 2. ln of 2. Oh my god. We have a half, 2. If the answer is ln of 2.
Yeah, that's it.
It's crazy. Yeah, I knew that it's like a Taylor series. It does look like an ln function for that Taylor series, but wow. I can't even tell what's in the denominator as well. It's very fuzzy. Dang. Very, very tricky integral. A double sum. Yeah, I'm pretty sure that looks like a double sum integral, but I don't know. I would have not known. Not know that how to even approach that integral. It's very, very tricky. Oh my god. So we're gonna go ahead and move on to the next integral. A very difficult start. Alright, so our next integral, here we go. We have the integral from 0 to pi over 2 cosine of x ln of cosine of x. I like how these integrals are like very fair game, you know. The other last two contestants, they had a piecewise integral and then an integral dealing with ln's and trig functions. We're about to see the same thing too. Oh, ln of 2 minus 1?
That's correct.
Oh my god! That was super fast. Wow. Very fast. Alright. Now he has more of a chance to win the semifinals, but let's see. We have one more to go. It's best out of 3. I hope the camera does not fall. But that was very fast. Very fast. Very impressive. Wow. Alright, next integral already. That was very quick. We have a pi product. Again, no mercy on these integrals. Integral of a pi product of n equal to 1 to infinity. We have a root, it looks like 2n minus 1. So we have x to the power of 1 over 2n minus 1, and then over x to the power of 1 over 2n. Oh god, we have a Putnam style integral. This is actually an MIT style integral. It looks like it. Oh, never mind. I lied. I'm over exaggerating. Yeah, turn that into. Notice that that exponent is a sum. So now the integral is x to the power of a sum of some sort of a weird telescoping sum. Now it's in a matter of who can do it fast. And do not lose accuracy. Do not mess up your summation computation. Oh, we might have an answer. That's his reference. All right. Oh, oh.
That is correct.
Wow. Very fast. Very nice. Moving on to the finals round. That's crazy.
And we have our second finalist, but very definitely deserves applause as well.
Very nice.
Okay, now get some refreshments, go to the bathroom before the two finals. We will have a 15-minute break.
Alright, we're gonna have a quick few-minute break before we get to the finals round. Wow. That was crazy. 2 integrals solved very quickly. Just like that. Very impressive. Right now we're just on break. If you need to go use the restroom, go ahead so that you don't miss anything in this live stream. Just a 5-minute break. So if you need to use the restroom, go ahead. Luck is a very huge skill, especially in speed integration. Definitely huge luck. A lot of luck actually plays in speed integration. The opponent, the integral given. Yeah. Very crazy. Very, very crazy. Yeah, definitely use the restroom if you need to. Those who are still here, well, just to kind of recap everything, in this Integration B Austria, we started off with a bunch of participants, and they all took the qualifying exam, and which helped filter out our top 16 participants. Yesterday, we did our regular round for 1/8 and quarterfinals, and that was exciting. If you haven't seen that, you can go watch it in day 1. Also somewhere in this channel, in live section. What else? Yeah, the finals round is going to be very, very crazy. Finals is going to have 5 minutes per integral, so a lot more time. But because it's 5 minutes per integral, I assume it's going to be so much harder, so much more devious. And not only that, it's going to be best out of 5, okay? Best out of 5. So it's going to be very, very intense. So definitely do not miss this for finals round. Again, competitors only have 1 guess. And you gotta take, you'd be very careful not to miscalculate anything. Other than that, how is everyone doing in the chat? Man, I'm actually very excited. It's going to be extremely intense for finals round. Cannot wait. I cannot wait for finals round. Man. Semifinals finished this quickly. It's been an hour now. We only been live streaming for an hour, so we got through the quarterfinals and semifinals very fast. So we are at a very good pace, actually. Yeah, this is extremely fun. Very, very fun, actually. I don't know if they updated the bracket on the website. Probably not. Oh, 15-minute break. I'm sorry. We have a 15-minute break. Holy hell. We can go ahead and take a look at the bracket right now. If we refresh, I don't think it has been updated so far. Yeah, it's not been updated yet. But that's no worries. 15-minute break. I'm more grateful that there's no lag, unlike yesterday. So thankfully there has been no technical difficulties today. No lagging, nothing. We are at a very good pace. Not so you know, today is gonna be a very fun, crazy day. Miracles might happen. I don't know. We don't know for sure for these competitors, but we are down to 2 contestants left now. It's going to be very intense. Wow. Is there anything I need to mention? I think that's about it. Just a 15-minute break. 15 minutes gonna feel long to wait here, so I'm exactly with all of you in the chat. I think I'm good. I don't think I need to use the restroom. I'm a little too excited for the finals round to use the restroom, so I can't. I hope that doesn't come out wrong, but. "15-minute break. Grab yourself a drink, grab yourself a snack, because finals round is going to be very, very intense." Alright, Silver, tell us a story. A story. I don't know what story to tell. Let's see. The story that I got eliminated on my first integration bee. Yeah, huge advice. Never try to show off to your audience, and never rush too fast. Always be accurate. Accuracy comes, well, it's more of like balancing. You have to balance speed and accuracy for speed integration. I learned that the hard way for my first integration bee. I got eliminated in semifinals, and I integrated too fast, and I integrated the wrong function. So huge tip advice: practice your accuracy, practice your speed. There will be a small final for 3rd place as well. Oh, okay, so I apologize. So before we get into finals, we're also going to have a 3rd place match. So a 3rd place match first, and then we do finals. Oh yeah, it's going to be very entertaining. 3rd place match is a little harder than semifinals, so don't get too relaxed up. What else? Oh yeah, I forgot to mention that the first integration bee I competed, it lasted until like between 12 to 2 a.m. It was very exhausting, but it was okay. Not only that, the first integration bee I competed, it was before they started the integration bee competition. They gave us a huge 1-hour lecture on why calculus is important, and I was dying of boredom of like being presented with like, oh, before you guys compete in integration bee, let me show you why calculus is so important. And then we were all just kind of dying out of boredom because we're all calculus nerds. We know why calculus is important. Let's get to the integration bee already. Oh my goodness. But yeah, that's the only story I have so far. I don't know what other stories to tell. Oh yeah, I forgot about the Putnam exam. Oh my god. That's right, the Putnam exam. Today is December what? December 6th? I think is the Putnam tomorrow? The Putnam exam is tomorrow? Yeah, it is tomorrow. Oh my god. To those who are taking the Putnam exam, I wish you the best of luck. To definitely prep. Get some sleep, actually. Very good sleep will definitely help you for the Putnam exam. Trust me. Other than that, I wish you the best of luck for the Putnam exam. Nice story, 9 out of 10. Thanks. True story, but yeah, speed integration is very fun. I miss competing. I don't want to say I'm retired, but I'm technically am retired because integration B is only for students, especially for undergraduates. Wow. I think it next year. Ooh, excuse me. It is very cold. I am freezing here at Minnesota. Living in the US, it's freezing. But I was told it's raining at Vienna. It's like cold, rain, dark. Probably like 50 degrees Fahrenheit. I mean, 15 degrees Celsius. I think that's warm, cold-ish. But anyways, I want to give Putnam to the G is ooh. For those who had to take the G exam, I also wish you the best of luck. I think the G exam is also close too. I think that's in January. The joint entrance exam. Holy hell. Also wish you the best of luck for that. I hope speed integration or integration B is very helpful for students in India who are prepping for the joint entrance exam. Because I heard integration is the most common topic that students avoid due to like math anxiety or like just kind of very like a discouraging math topic. Like I don't blame them, but I hope integration B would help gamify and motivate these students to learn and practice integration, especially solving it quickly. The 22nd of January. Oh my god. You have a month, almost over a month to study. Definitely wish you the best of luck. Yeah. Wow. Let me put on my second sweater actually. I am freezing. It is cold over here. Integration is good, G makes it hell. Okay, yeah, that's fair. Integration is fun until the joint entrance exam ruins it. They want answers in their own oh, that's right, because it's multiple choice. So there will be, okay. So there will be one technique you want to do, but then the multiple choice would be like, use Weierstrass to answer it in this format. I'm glad the integration B is not like that. I really am. Dear God. Rest in peace to those that have studied for that. Dang. Practice an integral, but you have to practice the same integral in multiple different techniques. That's crazy. Thank God we don't do that here in speed integration. Thank goodness. Am I thinking about making an integration B website? Unfortunately not, no. I'm thinking about making a problem book like Peter and Andreescu, but that's still a huge time process. I don't know, I'm debating on that. But I don't know how to make a website. I know nothing about programming, unfortunately. So the website I have is just Google Sites, because it's Google. Yeah, I'm sorry, I don't know how to program. If I can find someone, or if I can afford to find someone to make a website that would help all of us train for integration B, Do you need help with it? I would if you can make a website. I would love that. I did had someone also did mention to me too that they're also thinking about making an integration beat trainer similar to lead chess. And I'm just planning to help out provide over 1,000 integrals for them, categorized based on techniques and types of integral styles. The book, it's still in process. It's not entirely made. It's just a debate. I'm thinking about it. Make a website with Forma Mind. Oh yeah, absolutely. I might think about doing that. But again, if I have the money. I am currently a broke grad student, but everyone can understand, right? I hope so. Absolutely. Forma Mind would definitely be helpful. Absolutely. I'd love to help you if you need. I would really appreciate that. I'd buy a book. Oh. Y'all are sweet. That's actually I'm very grateful for that actually. We have about how long? We have like about 5 minutes until third place match starts. Maybe. Quickly, get a snack. I have my fruit roll-ups right here that I haven't finished. But I don't want to, I'm too scared to eat it because in case if I need to go starting to commentate again, I don't want to have food in my mouth. But it's okay. I have a drink though. I have my watermelon juice here so that my throat doesn't become dry. It looks like we might begin right now. Well, yep, here we go. We might begin third place match. Seems like we're about to start right now. All right. I don't know, but third place match is going to be very intense. Again, it's third place match rounds. The integrals are a little harder than semifinals, but we'll see. I heard cheering. I don't know what's going on in the background, but I heard cheering. But well, I think we're about to start.
But before that, we have a proposition from a member of the crowd, which I'm going to tell you, and if you want, you can do it. If not, then we don't do it. So as you saw before every integral, we have a counter that says 3, 2, 1, and for more interaction between contestants and crowd, and so that we help them more. The proposition from the crowd was that when those numbers come up, you all say 3, 2, 1, integrate. Alright. Okay.
Alright, so I guess we're all gonna count down. Countdown, chat. We're gonna be like 3, 2, 1, integrate.
I am very glad to start the small final between Weisgier and Bamberger.
Let me put the volume up further. Oh, okay.
Semifinal, so it is most of the week, and the interviews are going to be 4 minutes long.
Okay, no, we'll just so we are just beginning third place match then. Okay. I just want to make sure. All right. We are now beginning third place match.
And the crowd.
3, 2, 1, integrate! Oh my goodness, why? This is not the third place match I was expecting. God, when I say it's gonna be harder, I didn't mean it like this, but the max of sigma, there's so many sigmas, a little too much sigmas. The max of sigma, what is that G? What is that other symbol? G4? Excuse me, what? I can't really tell exactly what that symbol is, but from 0 to pi over 2, we have the absolute value of sigma 1 over sigma 2 minus sigma 3. Huh? Huh? Yeah, there's 3 sigmas. Oh no, there's 4 sigmas, I'm sorry. There are 4 sigmas. There's 1 inside of the sign. Holy sigmas. Yeah, already we are having a first difficult integral. Yeah, they're not explaining what it is to the commentator. It's okay. I can figure out by what on earth they're doing on the board. As you can see, I have no idea what they're writing on the board. I'm just kidding. I mean, kind of. I don't know exactly what they're doing. I mean, you could... I don't know if you could answer the integral like that. The person on the left just kept... Treat the absolute value as a constant, but I don't know if you need to separate that or not. But you are looking for the... You're computing the max of the integral. So... Ooh, 0. Incorrect. Yeah, yeah, there's something suspicious here. Yeah, no, I'm also stumped with this max integral. Jesus, I cannot even. I don't even know where to even begin with this. There's a lot of sigmas. Why do we have so many sigmas? I was gonna make a brain rot joke, but I don't. I fear to be cancelled. Yeah, the person on the left is. Yeah, I don't know. Is this a group theory problem? I really hope not, because I don't know how to follow through with this. Person on the left looks like to be drawing a diagram. The first thing came to my head was like a classification of group theory, but I don't know if it's some type of a tree or a graph, or I don't know what that is. But there's some sort of visualization that he's trying to see and figure out a pattern in this integral. But you have to be extremely careful to keep track, not to miscalculate 1. We have 1 on the side. Not fully circling yet, just to consider for last second case. I don't know. We have 5 seconds left. Square root of 2. Oh no, 5 over 2. 10 over 3. Where does that even come from? I can't tell. Yeah, I don't fully understand how to solve that integral. It's weird. It's a very weird integral. There's a lot going on in that integral. Finding the maximum for the amount of... It seems to be like a set of sigmas. Yeah, it looks like a G4. I'm not sure. But holy hell. Alright, we're gonna go ahead and get ready for the next integral. Alright, 3, 2, 1. Integrate. From 0 to 3 pi over 2? It looks like 3 pi over 2. I can't tell. Or 2 pi over 6? No. 2 pi over something. I think it is 3 pi over 2, yeah. But we have the tangent of inverse tangent of x minus arctan of tan x. So, of course the first term is x. But then that last term, oh god. It came back to haunt all of us, just like yesterday. The integral of arctan of tan x was an integral from yesterday, but now it has came back, and let's see if any of these competitors remembered how to tackle it. But we might not know. We have a graph on the right trying to help visualize the domain restriction. Oh, we have an answer? Pi over 4? That is incorrect. Person on the left seems to be... It looks like integration by parts. Because you have that minus x. Minus integral x there. He's trying to carefully make sure that what he's integrating is legal. Because there are a lot of mistakes that can go wrong. You just have to check if that's even correct. Because it does look suspicious. Maybe that x squared over 2 cancels it out because of the first term. But will he see it? Yeah, he'd be very careful not to mess this up. It's very tricky. Yeah, I think he's double checking, make sure there's no mistakes, no miscalculations. Try to solve this integral accurate as possible. 1 minute 40 seconds remaining, so enough time to kind of calculate the balance and also check at the same time. We know 0 is going to cancel out, so you just have to pay attention to 3 pi over 2. But just don't, again, you just got to calculate very precisely. Inverse tangent. Oh, tangent of 3 pi over 2? Yeah, he's carefully computing it. No rush. Being patient. Almost about 1 minute remaining. Yeah, tangent of 3 pi over 2. And he's just safely computing it because it does look very suspicious. Because notice that it's kind of a little divergent, right? But then you have that inverse tangent inside, so it seems safe, but it does throw you off a little bit. Oh, he might have an answer, but he's not sure. Oh no, just kind of expressing it first. 3 pi over 2 times pi over 2. Again, just making sure. There's 20 seconds left. Gotta guess, make an answer, or guess, before timer runs out. Come on. Very close, 10 seconds left, 5 seconds left. 0. Pi square. Dang. Yeah, it's a little it's a little very, I don't know, it's a little confusing. The domain, you have to be very careful with integrals like this. You have to be very, very careful. I don't really make or give integrals like that because there's a lot of controversy sometimes with like domain restrictions, what's allowed and what's not allowed, or how you compute it. I don't know. Pi square. No one has gotten an integral right yet. Alright, moving on to the next integral. Let's go. 3, 2, 1, integrate. The what? The rank? Excuse me? What in the linear algebra is this? The integral from 0 to 2 pi. Finding the rank of... Oh. Rest in peace. If you don't know linear algebra, if I was a competitor, I'd be a dead person. Because I know nothing about linear algebra. I completely forgot what rank is, actually. Not gonna lie. But why? Why would you do this to... This is third place match, you guys. And we're already giving so many difficult gimmicky integrals. Holy hell. Rest in peace to these two contestants. But they're persevering. Right now they're just trying to find the rank of the 4 following functions. Be very careful with that absolute value. That absolute value could cost you as well. You might have to do some balance splitting somewhere. Yeah. This is not freshman friendly. I agree. This is not freshman friendly. I don't know. I mean, they could be doing a different curriculum, but this is not what I expected. This really threw me off. Now they're just, at this point, they're just fighting to find the rank quickly, and then integrate, as well as carefully splitting the bound. Both contestants splitted the bounds. Yeah, they're both doing it very carefully. Yeah, rank is a linear algebra topic. I don't remember exactly what rank is. Something to do with matrices. I don't remember. But this is... They both seem to know what it is. And they both seem to splitting the bounds very carefully. 1, 2, 2, 1. That looks right, actually. Ooh. I think the person on the left might get it. Now you just have to be careful if you made any mistakes. Because you only have one shot at this. Only one guess. It's just a matter of who gets it first. Pi over 2, so is the answer 3 pi? Oh, come on. He's really checking his work. Just making sure. I guess you might answer 3 pi. Just make sure you don't get it before the first other opponent does.
That is correct.
Nice! Oh my god. He feels relieved. Crazy. Wow.
Congratulations to the third place. You're nice and fourth place. Very nice.
Nice. Very nice done. 3 pi. Yeah, I knew it looked correct. There was a pattern there. I'm just like, it must be. I was really having my anxiety like increasing because I thought the person on the right was gonna get it before the left person does. Like I thought the left person had the answer on the board but didn't circle it, and then the right person on the right might actually get it. But yeah, huge props. Very nicely done. Wow. Cannot believe that. A rank of an integral for a third place match. Can you imagine what final's gonna be like, you guys?
Okay, now we will continue with the grand final.
The grand finals round.
Award ceremony at the end, and I invite you all to watch that as well, so we can congratulate all of them. No. We both come here,
Oh.
and we have the grand final between Burda and Sul.
Alright. So we are going to begin our grand finals. Let me lower that for you. There we go.
I will remind you of the format. We have 5.
We have our last 2 contestants now. This is the moment.
Out of 5 integrals. And again, if you want, you can help them with their countdown at the beginning.
Yeah, it's going to be crazy. Best of luck to both of these contestants. Making it this far is not easy.
Let's go.
Adrenaline is kicking in very quickly. 3, 2, 1, integrate. Oh my goodness. The limit has n approached to infinity. We have 2 infinite functions. Ooh. I'd start generalizing. There you go. Person on the left quickly try to generalize, solve for the infinite function. Very nice. Both are very fast. Very scary. Holy hell. The golden ratio already. Both are solving for the infinite function very quickly. Ooh! Ooh! 1 over... Oh, wait. 1 over the golden ratio? Oh, but then you have the other term. You gotta be very careful. Very good catch. Oh my god. Both are actually trying to generalize it very quickly. This is gonna be intense. 2 speed integrators going at it. They're seeing a lot of golden ratios. We just have to try not to mess up and juggle with it. Root 5x.
That is wrong.
Oh wait, but they accidentally showed the what? Oh, did they? Ooh.
No, stop. We move to the next interview. I'm sorry, the answer was shown.
Yeah, I figured the answer was accidentally shown. They accidentally showed the answer. Damn. Root 5, but then he forgot the integral was... He forgot the integral was head bound. Dang. Oh, that is so unfortunate. Oh my god. The person forgot that there was bounds. Yeah, no, that was just a mistake. Oh no. No, not in finals. Don't buffer. Do not buffer on finals round. No. I'm gonna delay a little bit. Oh my god. That is very unfortunate. Forgot about the bounds from 0 to 1. Yeah, that's the huge the biggest thing about going too fast is you can when you're rushing and it's yeah. That's the big downside of like going too fast sometimes. Oh my god. That was very unfortunate. Alright, moving on to the second integral. Alright, 3, 2, 1. Integrate. Another golden ratio? Oh no. Is this... What's that formula called? Binet's formula? Something like that? That's what that looks like. That looks like a Fibonacci number. So are you adding up all the Fibonacci numbers? Oh. I think person on the right realizes it. Yep. Oh. Now you just have to compute the sum. Oh. No. Person on the left is rewriting it. It's too much time. Oh, it's wrong. From 0 to... Oh, wait a minute. The ceiling function. That's a ceiling function. Oh, no. I don't think he looked closely enough to realize that was it. It was the correct way to do it, but it was by an integer off, I think. Yeah, Binet's formula. You just compute the sum of the Fibonacci numbers. Huge props for not looking over the board though. That's very huge props. Root 5 over 2? Oh, no. Oh, it's a... Oh, God. Never mind. I was wrong. There was a lot of irrational. Yeah. Never mind. I would have never guessed. Wow. Yeah, that's pure evil. That is pure evil for finals round. But I mean, what? It's It's no mercy here, so what do you expect? Dang. A Binet's formula integral. That's... Ooh. Alright. Moving on to our third integral now. Alright. 3, 2, 1. Integrate. Oh my god. The integral from 0 to pi over 2, the sum of k equals 0 to infinity, negative 1 to the power of k. The k squared derivative of sine of x, all to the power of k. Oh, they need to generalize that fast right now. And then it becomes kind of a geometric series. Yeah. You need to generalize that now before the other opponent's gonna get it. The trickiest thing is how you're gonna generalize it in terms of k. Let's see, k squared derivative to the power of k. Oh wait, never mind. That's all in the sum. Okay, no, forget what I said. This is k squared. That sum is with that derivative. So you're summing with from k equals 0, k equals 1, and you're deriving the sum again. An alternating sum with the k squared derivative. Oh my god. This is definitely an MIT style integral, I would say. You just have to do it. You have to be very... There are so many warning things that you have to be very careful about. Not only generalizing it, but you have the k to the power. You can also miss that. The negative 1 to the power of k, forget that it's alternating. Because the derivative of sine is already an alternating periodic derivative itself. And then integrating from 0 to pi over 2. Both are trying to generalize it, trying to kind of simplify this as possible. But at the same time, you have to be careful not to rush too quickly and forget something. Both are being very, very careful. But at the same time at a very good pace. Speed pace. We have 3 minutes remaining. Wow. Person on the right is erasing work and trying to find another approach. Ooh, I see the person on the left is manually summing it. That's actually very good because you're trying to be careful, see a pattern, and rewrite the sum yourself. So you're deconstructing the sum and then integrating. You can also do that too, just integrate by each term and then find the sum pattern based on the answer from 0 to pi over 2. That's what it looks like. The person on the right is trying to... we got some alternating 1s. Again, yeah. You have to be extremely careful. Because again, you only have one guess. It's not that many attempts that you can have. Oh my god. I don't even know how I would even approach this. This is... the k squared derivative is super evil. K squared derivative. And that k squared is interacted with that sum, as well as the k power and the alternating series. The negative 1k. Very evil integral, I would say. This is extremely evil. Yeah, there you go. Now the person on the right is doing the same approach as the person on the left. Now it's just who can do it faster. Okay, tan square. Oh, we might have an answer. Pi over 2. No. Ooh. 1 minute remaining. We're about to have 30 seconds remaining, actually. Both are very good progress so far, this entire time, but You have one guess. If last second. This is going to be crazy. About 15 seconds left. They need to come up with something very quickly. Come up with an educated guess what it looks like. 10 seconds. 0? No. No, I highly doubt it. Pi. Dang. 1. That is evil. That is really, really evil. Oh my god. That is extremely evil. Jesus. They were both at a very good progress, actually. They both try to write down supply as fast as possible. 5-minute frame. But that's... oh god. It's crazy. Looking at how these finals round integrals are, these are very extremely difficult. Super extreme. I'm not sure if they're going to post the problems, but I usually post the problems on AOPS. Usually later on. Other than that, the problems are also here in the video, but I know some viewers, it's hard to see the board. But I don't know if they're gonna post the problems, but I could also, if it's helpful, I could also just post the problems in AOPS. But I think we're about to start the next integral now. Alright. 3, 2, 1, integrate. Again. I mean, I'm not surprised at this point. Integral from 0 to infinity. We have a sum inside of a log. Oh god. A sum inside of a log. Okay, notice that we have -1 and x to the power of n. It's definitely some type of geometric function. A geometric series function. It's not an infinite series. But it's all over 1 plus x squared ln of x. What I would do is I would keep it as a sum. I would honestly keep it as a sum. And then do an inversion. Because I think... let's see, I think it'd still keep it as a sum. You only have, what, negative ln of x by itself? Yeah. Ln of x. So you should be left with... so you'll be left with the integral of 0 to infinity dx over 1 plus x squared. So the answer might be pi over 2. Ooh. Now this is crazy. The answer might be pi over 2 if you do an inversion. Now, the question is who's going to get it first. Both are trying to deconstruct that sum, turning it into a geometric function. I'd leave it as a sum, but I don't blame both of these contestants because it's very hard to see. That sum is really distracting. It is very discouraging. But you know, in finals round, we don't have time to get problem shock. We just gotta start somewhere, and they both start somewhere very quickly. It's a very good starting point. Good start off, sorry. But ooh. Person on the left is really trying to simplify that sum, trying to find a way to kind of make it nicer for the integral, but I don't think you can. Ooh, oh no. Person on the right did turn into a geometric rational polynomial, but then now he has to deal with 2 different integrals. And it's nasty. Oh god, they're both at a very disgusting form of integrals. They're both at... oh, I think they're both at the same position now. But it's a very ugly formation of integral right now. I would have left it as a sum. But that's... I don't blame them. It's very hard to see. You could still... there's still time to do an inversion. There's 2 minutes remaining. but I don't know if they're gonna catch it. Oh, person on the right is doing inversion now. U equal 1 over x, or a over x. Looks like a 1. I think it's a 1 over x. I don't think you need any constants on top. Oh, who's gonna get it? It looks like pi over 2. Oh, it might be pi over 4 actually, because you have 2i. So the answer might be pi over 4. Yeah, who's gonna get it first? Oh man. They're both stuck at the same integral formation. They are both stuck at the same integral formation. It's just... Come on, who's gonna see it first? Oh, the person on the right might notice something. I just hope they don't mistakenly rewrite the wrong integral. Oh. Oh no. They're just there. But it's very hard to... Oh! Yes, come on. Very close, very close. Person on the right is at a great... Oh! Oh, we might get it! Pi over 4! Oh! Come on, now you just had to circle it. Oh, but... I think he's checking his work. Yeah, because you only have 1 shot. Oh, 15 seconds remaining. Come on. You just gotta circle it. Do not guess any other answer. If you think it's the answer, just circle it and guess. 10 seconds left. Pi over 4. Come on. Oh. Come on. It has bounds. It's not. Oh no, they didn't. Oh, what? 506 pi. Oh, because of the exponent. Dang. So close. Yeah, I would have not gotten that. I would have completely forgot about the exponent. That's evil. Yeah, I forgot you have that exponent there. So you're gonna get x to the power of... Oh my god. Yeah, you have x to the power of 2025, and then you have 2025 times pi over 4, and that simplifies it to 506 pi. Dang. So close. The person on the right was so close. Just completely forgot about the exponent, the coefficient. Dang. Still not a single integral solved yet. Still in finals round. Try and get best of 5. Damn, it's getting very intense now. Alright. We are at our 5th integral now. Here we go. 3, 2, 1. Integrate. Oh my goodness. What in the sup and inf? Why? Is this real analysis? Oh yes. Hangman. What is this? No, I'm exactly in the same boat as you are. I don't even know. I mean, I do know what sup and inf is, but I don't know in terms of integration. Is that a factorial? I just realized that. X plus a floor factorial. What in the abomination? Oh my god. Yeah, if you've never taken real analysis, you're doomed. Yeah, this is kind of out of the scope of what I was expecting. Yeah, because I have no idea how you're gonna approach this. The person on the right is just... there's a picture diagram to help visualize as a reference, and then solving each term at a time. Oh my god. Supermum and infimum. That is evil. Not even MIT would... Well, okay, maybe MIT would probably do something like this, but... This is like, this is torture. I honestly feel more bad for the person on the left because it's like, how if you don't know what sup and inf is, then there's literally no point of this integral. How would you even approach it if you don't know what the definition of these gimmicks are? We have 3. Okay, so the person on the right is doing casework. I do find this integral to be a little unfair because it is kind of out of the scope of what's expected. But 1. I was about to say, if that was correct, I would have flipped. Wow. I feel so bad. This is like, I feel the exact same thing for the person on the left because it's like, what even is that? Like, there's literally no point of trying if you don't know the definition of, you know, the sup and inf. Now, I was not expecting that, but the person on the right is really graphing, really doing casework, trying to count cases, making sure, you know, that it really is the least upper bound, making sure that it's the greatest lower bound. Dang. Yeah, I don't even know how to approach this. And the fact that there's factorials is just insane. But I mean, it is nicely enough that it's from 0 to 2. But I mean, look at that. Like, oh no. One minute and 30 seconds remaining. Yeah, I don't even know how to approach this. There's no way. You gotta be super lucky to, like, get this right. Pi square over 2 minus 1.
That is also wrong.
Dang. 6? The answer is 6. Yeah, I don't... That's kind of an unfair integral, to be honest. Very, very difficult. Yeah, I don't blame any of these contestants. It's really out of pocket. Just an infimum and a supermum out of nowhere. With the factorials. This was extremely, extremely difficult to integrate. Especially in a time limit. Dang. So we went through 5 integrals now. I don't know if they're gonna get into tiebreaker. Not a single integral has been solved yet. Not solved properly, I mean. The first integral, I'm still bummed about that first integral. Very, very close. Just forgot about the bounds. But I think they're gonna start tiebreaker now. I don't know if it's gonna get any easier.
Move to the fifth integral. Since it's still 0-0, this basically has the same effect as a tiebreaker. But it's still a final integral, still 5 minutes, still.
I really apologize about that. 3, 2, 1, integrate. Alright, we have the limit as n approaches to infinity. From 0 to n, sine square of n of x over n. Oh. Shoot. You have to be very careful not to mess this up. There are so many traps that can happen in this limit integral. 1 over n. Ooh, actually, that's actually a great start. I would but then that n is at the upper bound. Oh, that's evil. You can't really do anything much with that upper bound. Oh god. It looks like a Dirichlet integral, but I was planning, you know, maybe put a, you know, multiplying the n on the bottom and then multiply another n on top, and you get like a square of sine of n of x over nx. Oh, you might have to multiply x squared top and bottom as well, and then get rid of that limit. But then that n on top is so distracting. But that's my first approach. Just try to test if I can multiply nx squared. But then that n, you have an extra n. What are you gonna do with that n? So it's really trappy, a very trappy integral. You have to be extremely careful not to do anything illegal. Yeah, limit integrals, you have to be extremely careful. Make sure that you don't dive into divergence. You don't want to mess this up. Yeah, both are trying to utilize trig identities. The person on the right is using a graph. Try to visualize it, see where it's approaching as a whole area. The person on the left is just really bashing it out with trig identities, trying to simplify it in a way that's integrable, at the same time trying to find the limit easier. But both are really trying to quickly solve this. You have to be very careful not to get it wrong, because it's an extremely trappy integral. You do not want to dive into divergence. You don't want to. You need to make sure that you're not doing anything illegal. From 0 to 2 pi sine square. Yeah, that looks very suspicious. Yeah, I wouldn't trust that integral either. Because it wouldn't equal to. Oh no, it would equal to a half, right? But then you have 0 to 2 pi, so you end up with pi as your answer. Okay, I thought the integral was going to equal to 0 at first, but then that might have a converging number. But no, you have to test some cases out. I don't know, but the person on the right is going with the sine square. Oh no, I really hope he didn't mess up the trig identity. Sine square is 1 minus cosine 2x over 2. Oh no. I really hope he didn't mess up the... Unless there's a negative, but... I just hope he... Okay, I'm glad. Very nicely he caught that. That would have costed him. Yeah, you have to be extremely careful when you're rushing. Trying not to lose accuracy. Person on the left is really rushing though. Trying to compute the integral. It looks like they're at the same boat. It looks very similar to the integral that the person on the right has. So a half. Oh, that might be. Ooh, that looks legit. 1/2? Oh, now you just gotta circle it before the person on the left does. Oh, they both have 30 seconds. Oh, we have a half?
Integration V Vienna is a new winner!
We have a winner! Oh my god! Wow. That is crazy. Very nicely done. Holy hell. 1/2. Extremely nice. Very nice. We have a grand integrator for the Vienna Integration Bee Fall 2024. Amazing. Wow. 1/2. It's a very trappy integral. There's so many things that can go wrong. But wow. Very lucky. If he didn't caught that 1 minus, you know, the sine squared trig identity, man. Very nice. Very lucky. That was insane. But now we have our Integration B winner for Austria. Amazing.
Okay, we continue now with the closing ceremony. This will mean every single one of the contestants will be invited here. If it's present, and we will receive a certificate. The top three will receive a prize. We will also have to thank you and the volunteers and shortly the sponsors again. And then we are done. I'm also going to announce shortly some future plans. So let's go quickly through all the points. First of all, if you haven't done it already, please follow us on YouTube. You can show your sisters, your friends, your mothers, tell them you were here and they can see the live stream. You can care about individuals or about young, smart, and bright students. Also on our Instagram, you can see the latest updates. You can see our future plans. And you can obviously also see all the pictures from this event. If you want to see how you look in them or how your friends look in them, also on our website. So,
oh god, a little buffer there.
this is the team, we can skip it already, you know it. The rest of the team, and we want to thank these people. And now about the future plans. So first of all, just so that we don't announce it 2 weeks before, like we did this time for logistical reasons, I already announced it that the future integration meeting will be 99% sure in the last weekend of May. So there is almost 6 months until then. You can prepare if you didn't have the courage to participate this time. You can prepare even more if you participate this time. If you have friends who think they would like to see this or to participate, please come. Next time, hopefully, we'll have more than 16 registered participants. So we will also have a preliminary test, which traditionally will be 1 week ahead of the integration week. It will probably be exactly here, the last weekend of May. Moving on, we have the prizes. And for this, I'm going to start in a logical order. So first, I would like to invite the people who reached the 8 finals of the event. If they are not here, but any of you is friends with them, please come and take their certificate in their place so you can transmit it. So first, I invite Pablo Shea for the 8 finals.
Yeah!
Please remain on stage. We want to take a picture with everyone at the end. Next, this is no order, it's just how these were handed to me. We have also for the 8 finals, Kilian Rommel.
Nice. I can't exactly clap, otherwise the mic is gonna.
Moving on, we have also for each of the 8 finals, Bruno Steinmetz.
Yeah.
A first time participant, just like Pablo. Now we move on to Severin Obi.
Very amazing contestant.
Last time in our first ever event while being still a high school student. So yeah, he will be here twice. Now we move on to William Shi. One of you will take it. Okay. We continue with Josef Lesnar. He's not here. Does he have any friends here? I heard someone yesterday say that he's a goat. So. Last but not least, from the 8 finals, we have Martin Bierbauer. Okay, moving on to the contestants who reached the quarterfinals, we have Jörg Wiegel. Moving on, we have also for the quarterfinals, Denis Kuski. Lucas Kuhn. And last but not least, also for the quarterfinals, I hope I can say this right, but you're already here, we have Alexandra Sierikova. And now the freshly written last 4 certificates arrived. So, popular fan favorite, 4th place, Erik Bramberger. Who, in our opinion, probably wins the award for the outfit of the tournament from yesterday. Just 1 second, I have to bring the prizes for the first 3 contestants. Santa Claus arrived. Okay. Moving on to the 3rd place, the previous winner who will receive a special gaming mouse, we have Jörg Weisbier. George Weisbier. Okay, moving on to the 2nd place, and receiving from the same popular gaming brand, I'm assuming for the gaming community, we have a gaming keyboard for Xiao Suo. And last but not least, the new master integrator who will receive a prize I will say now, and then you applaud him, and then I will show you the secret prize. So, we have a gaming headset for the new master integrator, Dominic Pulda.
Yeah!
All of these prizes, the 3 prizes, are sponsored by the brand Smaragdis from Vienna, and this is of course your certificate. And now you can go to the next slide. Does anyone recognize the person behind me? I hinted at this. The person behind me is Professor Dr. obviously Anton Seininger, who won the Nobel Prize in 2023 for his contribution to quantum mechanics. And he can come back, Dominic. Or Dominic, special because Professor Anton Seininger heard about this event when he actually answered us, and he liked the event, said that he couldn't come. We have an Integration League Vienna t-shirt signed by the professor.
That is nice.
Let's take some pictures of the contestants. I'm moving closer, yes.
And a huge congrats to the contestants. And a huge appreciation for participating.
Wait a second, because we want to make up for the fact that we ended it so early last time. I want to invite all of you to come here for a picture, or whoever wants to come.
Wait, put me on the screen.
Come, support your friends.
No, I'm just kidding. Okay, I'll be like the narrator. I'm in the picture, just by audio. Yeah, huge appreciation to everyone organizing, spectating, participating for this integration bee, including you guys in the chat.
Yeah, with the winning integral on top.
I think everyone would fit.
Should we do one more 3 to 1? 3 to 1 cheesecake. Yeah. Okay. 3, 2, 1.
Cheesecake!
One more. Someone please.
Three, 2, 1.
Cheesecake!
Alright. Thank you all so much.
Yeah! And also thank you guys for coming by in this live stream. That is the end of Integration Bee Austria Fall 2024. Thank you guys so much for coming by. I really appreciate it. Showing support for the contestants. And yeah. Huge thanks to the organizers and everyone who organized Vienna Integration Bee for having me to commentate. I am very honored to be here. Yeah. Definitely stay tuned for the next Integration Bee. And yeah. You guys have a great day.